Hello friends, myself Professor R.S. Kognole from TSSM Bhivarbai Sawant College of Engineering, Nare, Pune. Today we'll be discussing few numericals on compound pipe. In my previous sessions, we have discussed the concept of compound pipe. Now we are going to see few of the examples which are how it can be solved. So let us, in short, discuss the concept of compound pipe. Compound pipe is a pipe where number of pipes with varying length and varying diameter are connected to each other. The difference between the water surfaces in the two tanks is nothing but the head loss. So, head loss is the difference between the two water levels which can be measured over here. Now, here we have two conditions which we need to consider. The condition is going to be for first is going to be for discharge. Now, water flowing through this pipe is same. So here constant. So we can say that the discharge flowing through this pipe is going to remain constant. So we'll have the continuity equation is the first condition, that is Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. And the second condition is this head loss is nothing but is equal to two losses which we have discussed previously. One is the major loss and another is the minor loss. So major loss whatever we are going to have, that is going to be due to the friction, and minor loss we are going to have, that is going to be, let's see which are the parameters included in this. So here minor loss we'll have one, the flow due to entry, the loss due to entry, sorry. Next, here we can see there is a contraction in the pipe. So first is due to entry, next is due to contraction. Here at this section if we see, we can see the expansion in the pipe, so loss due to expansion, and when the water flows here it is going to exit in the tank, so exit loss. So four minor losses we are going to have: exit, contraction, expansion and entry, contraction, expansion and exit. So entry equation is 0.5 v square by 2g. Contraction equation, as cc value if it is known, then it is going to be 1 upon cc minus 1 whole bracket square divided by 2g into v square. So that is going to be the equation for contraction if at all, and if at all cc value is not given, then we are going to take the equation as 0.5 v square by 2g. Here at the expansion we are going to have the equation as v1 minus v2 whole bracket square divided by 2g, and at exit we are going to have the equation as v square by 2g. This is all about the minor loss. And let's see about the major loss. Major loss is given by Darcy-Weisbach equation, which is nothing but FLV square divided by 2GD. So this is the equation for the major loss. Now let us write the equation. This is the first condition which we had discussed. The discharge is going to remain constant, and the second condition is this. This is the complete equation. H is equal to all the losses. So H is equal to, we had discussed all the losses. First we are going to have the entry loss. So entry. Then once the fluid flows, the liquid is going to flow in this pipe. So friction loss. So this is the friction loss. Next we are going to have the contraction loss, 0.5 v square by 2g, as the cc value is not known to us. Next the fluid is again going to flow through pipe number 2. So here we are going to have the frictional loss. Next expansion loss. So this is the expansion loss equation. Next is again friction, and last is the exit. All these equations include in this are for the losses which are going to be incorporated. If at all it is said that neglect the minor losses, so if I neglect this, H is nothing but the major loss. So major loss will incorporate in this pipe and this pipe. So friction, summation of frictional loss in the three pipes will be the head loss. So we will have only and only the frictional loss, and this will be the equation, that is H is equal to 4 FLV square divided by 2GD. That is going to be the equation. Now we have taken it as 4 FLV square because 4F is considered, because here 4F is nothing but the coefficient of friction. If we consider only and only F, then that F represents the friction factor. These all concepts are previously briefly discussed. This was the short which we have discussed. Now let us see the numericals related to it. First numerical which we are going to discuss here, we can have a difference in the, I'll read the numerical, the difference in the water surface level in two tanks which are connected by the three pipes in series. So there are three pipes in series of the respective lengths 300, 170 and 210, and of diameter 300 mm, 200 mm and 400 mm respectively, is 4 meters. So we came to know that difference in the water is 12 meters. So H is the difference between the water level, and that comes out to be 12 meters. So respective lengths and respective diameters are given. So these are the lengths and these are the diameters which are given to us. Determine the rate of flow in the pipe if. So Q is to be determined, rate of flow in the pipe is to determine if the coefficient of friction. So F values are given to us, F1, F2 and F3 are given to us. Consider minor losses. So we have to consider the minor losses also. So major loss and minor loss both are going to be incorporated. Accordingly, the given data is written. H is written L1, L2, L3 respective D1, D2, D3, F1, F2, F3. These are the given data which are written over here. Now we have the first equation. Before solving the compound pipe equation, we have to write the two conditions which we know. What are the two conditions? First condition is Q is equal to A1 V1 is equal to A2 V2 depending on number of pipes, and the second equation is H is equal to HL. HL is nothing but the head loss whichever we have, and that head loss incorporates major losses as well as minor losses. We have considered the minor losses because it is given in example that minor losses is to be considered. So using the first equation, that is the continuity equation, this is the continuity equation. Now here if we see, as diameters are known, A1, A2, A3, these values are known to us. Now V1, V2, V3 as discharge is known to us, it is unknown for us. Now what we have to do is convert V2 in form of V1 as well as V3 in the form of V1. So how we can get this? First, if I equate A1 V1 is equal to A2 V2, I'll get the relation of V2 with respect to V1, and then if I write the equation, that is A1 V1 is equal to A3 V3, A1 is known, A3 is known, I'll get the relation between V3 and V1. The same is done over here. So V2 is written in a form of V1 and V3 is calculated in a form of V1. So V2 can be written in a form of V1 and V3 also can be written in a form of V2. So with the help of the first equation we have found out this. Now we are going to use the second equation, that is H is equal to HL. That is the second condition which we have. Now in this HL, let's see what are the major losses and minor losses. So first, if we see the diameters of the pipe, first is 300, second is 200 and next is the 400. So first diameter whatever we had, that was 300. So first was 300, next is 200 and next is 400. So here we have 300, 200 and 400. So these are the losses. First pipe whichever diameter is 300, that is this pipe. Next 200 is this pipe and 400 is this pipe. So let's see what are the losses. First, the fluid is going to flow through this pipe, so entry loss. Then the liquid is going to flow in this pipe, so frictional loss. Then at this section we are having contraction, so we are going to have the contraction loss. Then the fluid is going to flow through this pipe, so there is going to be frictional loss. Next, at this point the pipe have expanded, so sudden expansion. Next, the fluid is going to flow in this pipe, so again frictional loss, and the fluid is going to exit in this tank, so the exit loss. So entry, friction, contraction, friction, expansion, friction, and exit, these are the respective losses. So accordingly we have written this equation for the head loss. H is equal to 0.5 v square by 2g is for entry. Next, friction in the first pipe. Next, contraction, as Cc is not given, it is 0.5 v square by 2g, so we have written that equation. Now here we have v2 over here for the respective pipe. The when take the contraction case, that time the velocity for the smaller pipe or the higher velocity is to be considered, so v2 is taken over here. Next, the friction in the second pipe, so we have this equation. Expansion is going to be, this is the second pipe, so it is v2 minus v3. Expansion is taking place in the second pipe and the third pipe, so it is v2 minus v3 square divided by 2g. Next, the friction pipe, and then the frictional loss, and then the exit loss. So in all these losses, if we see, the unknowns are v1, v2 and v3. Rest other all parameters are known to us. Now what we can do is, v1 is unknown, okay, v2 over here and here can be written in a form of v1 which was previously derived. Here in this equation, v2, v3, v3 and this v3 is written in the form of v1. Means in this equation the only unknown whatever we'll have is going to be v1. And once we write this equation in the form of v1, then the only unknown becomes v1. So this was the previous equation which was taken, and here by substituting v2 and v3 respective v3 we get this, and when we solve the only unknown is v1, so we'll get the value for v1, and v1 comes out to be 1.407. We know the equation q is equal to a1 v1. From this equation, q is known to us, v1 is known to us, a is known to us, and discharge can be calculated, which was asked in the example. We were asked to find out what is the determine the rate of flow of water. So we had asked, it was asked to calculate the discharge, and discharge is calculated in this example. Hope the concept is understood. And now in the next example, let us see in this example what is given. Here sometimes we have that in the cases we have to neglect the minor losses as well. So in this example we are going to neglect the minor loss. Let's see the example. Three pipes of the diameters of 400 mm, 200 mm and 300 mm diameters have length of 400 meters, 200 meters and 300 meters respectively, are connected in series to make a compound pipe. The end of this compound pipe are connected with two tanks whose difference of the water level is 16 meters, means H is given to us as 16 meters. The coefficient of friction means F value is given, wherein we need to incorporate the equation as 4 FLV square, because the coefficient of friction is given to us. So coefficient of friction from this pipe is given equal for all the pipes. So F1 is equal to F2 is equal to F3. The value is going to be 0.005. Determine the discharge flowing through the compound pipe, and we need to neglect the minor losses. So minor losses are going to be neglected. So which two equations we have? The first step is to write the condition. So the condition is Q is equal to a1 v1 is equal to a2 v2. This is the first condition, and the second condition which we have is H is equal to HL. HL is actually major and minor, so major loss and minor loss, but minor is to be neglected, so HL will remain. Only and only is the major loss which we have to take into consideration. From like previous example, as we know the area of the pipe, so from this equation we will get the relation of v1 is equal to something in terms of v2, or v2 is equal to something of v1. So v2 will be represented in a form of v1, as well as V3 also we will get in form of V1. So V1 will be the only unknown in our equation. Now let's see about this condition, that is H is equal to H. Major loss is only and only due to friction, where we are going to use the equation 4FLV square divided by 2GD. So this is the condition which we had seen. In this condition, now this will be the equation. H is equal to 4FLV square divided by 2G. Summation of the three pipes is going to remain same. Here V2 is written in a form of V1. V2 is written in a form of V1 and V3 as well is written in a form of V1. So now we have the values of the unknown as only V1. So V1 is calculated as 0.882. Once knowing it, writing in an equation Q is equal to area into velocity, we will get the value for the discharge which was asked to us. Hope students you all have understood the concept of compound pipe and you will be able to solve the numericals on compound pipe. Thank you.